Welcome back to the Scotti-BYTE channel, and this is Scott. So back in last May and June timeframe, I introduced the concept of LXD Virtual Machines. And this time, we're going to discuss enlarging a LXD Virtual Machine disk. So I covered creating an Ubuntu LXD Virtual Machine in June of 2022, and as I said, initially in May, I covered what are LXD virtual machines, and then I had two tutorials after that, which were about how to create a Windows 11 LXD virtual machine. That was rather detailed, but I encourage you to look at it if you want to create a Windows 11 LXD virtual machine. So LXD VMs provide a means to have a dedicated software emulated kernel for applications which require it, with the advantage of all of the LXD CLI features. And LXD containers are more efficient, but they share the host kernel. So if you have an application that requires the application to be able to modify the kernel or work with different kernel features, a LXD container, although being highly efficient, might not be your best choice. And so that's why a LXD virtual machine might be attractive. So LXD containers also share space in the LXD pool space cooperatively. And we've had several videos on the channel where we talk about the LXD ZFS pool, which is created by default when you initialize LXD, and how to enlarge it. But LXD virtual machines have dedicated disk images, pretty much like a virtual machine that's created by any other hypervisor, like maybe VirtualBox or Hyper-V. So what's the problem with this? Well, traditional hypervisor-based virtual machines require you to install the operating system from an ISO image. So you go through all the steps of installing the operating system just as though you were on bare metal, and that's what most people are used to when they create a virtual machine. They create the virtual machine and then they do the operating system installation. But LXD VMs don't work that way. They download a pre-configured image that does not require any sort of an installation, which is fantastic for rapid prototyping. But the pre-configured LXD container VM comes with a default disk size of only 10 gigabytes, and you can run out of that pretty quickly. So there is a command, a LXD config device override command specifically, that can enlarge that disk after the LXD VM is created. But the larger disk is not available for use until you enlarge the partition inside of that disk and then grow the root file system size inside of the partition. So let's go see how we can do that. In the last May to June timeframe, when I was discussing LXD VMs, if you would do a LXD list on this particular host, you will recall that we had created an Ubuntu VM and we had created a Windows 11 VM, and those are in those other videos. You can tell that these are LXD virtual machines and not containers, because under the type field it'll say virtual machine as opposed to container. So for the purposes of this video, we're going to create ourselves a new container, and this particular container we're going to do with the LXD init command instead of a LXD launch. The only difference is the LXD init command will create the container and not start it, whereas the LXD launch command will create the container and start it. So I'm going to make this container images :Debian/11, which what that will do is it will create a server version container that is a virtual machine for Debian Bullseye. We know it's a virtual machine because of the --VM. We're calling the machine test-VM, and we're applying the default profile to it because we always apply the default profile when we create a new container. And then I'm also applying the bridge profile because I want this container to be available on my main LAN. And I have several videos which discuss how to set up a bridge and how to configure it both on your host system and in LXD. And then we have the boot.autostart equals to true, which just means that every time the system boots up, this virtual machine will start automatically. And then we have another switch called limits.cpu equals 4. And what that one does is it goes ahead and sets the CPU operational limit to be 4 threads or 4 virtual CPUs for this particular VM. And then it caps the memory out at 4 gigabytes of memory. So we hit enter and it will create this VM. It will download the root file system and start it for us. And you can see this is a pretty quick operation. It is unpacking the VM and creating the root file system, and there it goes. So if I do a LXC list, our VM is completely created, installed, and initialized, but it is not yet started. Let's get into this VM and see what it looks like. And we're going to do that with the LXC exec test -VM and the BOSH shell. Make the screen a little bit bigger so you can see it. And we are not able to get into it because, of course, it's not yet started. So we're going to say LXC start test -VM. And now that it's starting, and now that it's started, we can go ahead and do the LXC exec test -VM and enter the BOSH shell. So it will take a minute before this VM will actually be up and running. It takes a little while to boot, a little bit longer to boot this than it does to boot a container. And now we're into it. And so the first thing I want to do is a DF. And so it says that we have just about 3 gigabytes available. Actually 3 megabytes it looks like. And it's saying that there's a relatively small amount used. So we already have 22% of its disk used. And we really don't want that. We want to enlarge this disk, which is the subject of this video. So what we do is we exit out of this thing and we go ahead and do a LXC stop on test VM, which will go ahead and do an orderly shutdown. So let's go ahead and make our disk 100 gigabytes, and we're going to do that with the LXC config device override test-VM root size equals 100 gigabytes. And we go ahead and do that, and it says device root overwritten for test-VM. So let's start the VM back up again. And then let's go ahead and connect to it with the LXC exec test-VM in the BOSH shell. And again, it's not running, so we have to wait for just a minute for it to start. You get so spoiled with LXD containers starting really quickly, the VMs take just a little bit longer to start. And there we are into there. So if we do a DF again, you'll notice that none of these numbers have changed. SDA2, the root device, is still at 22%, and it still has the same amount of available disk space. To actually enlarge the file partition as well as the file system, first we're going to need a utility called cloud-guest-utils. We do an apt install on it. And the second utility that we're going to install will be fdisk. Now that we have those two utilities installed, the next step is going to be invoking a program that comes from the cloud utilities called grow part. And we say grow part /. dev/SDA, and we leave a space and we put a 2 because you would think you would say SDA2, but the 2 means the second partition on that disk, and it uses it as a parameter. So we hit enter on it, and it says that it has enlarged the partition. And finally, well, I can see here if we do a DF, you can still see that it is really doesn't look like it's changed too much. It says 25% now. It's actually used more space. It was using 22% before, and so it really hasn't gotten any larger. And that's because the last step that you're going to need to do is to resize the file system inside the enlarged partition. And we do that with a resize 2fs space /dev/SDA2, and here we use the name SDA2, and the 2 is not a parameter. So we hit enter on it, and there we go. So finally, if we do a DF, you can see that we're only using 1% of the disk, and we have a 100 gigabyte disk now. So in summary, in this tutorial, we learned that a LXD Virtual Machine has a default disk size of 10 gigabytes. We learned that you can apply a device override command to enlarge the LXD VM disk. We also had to grow the partition size to match the enlarged disk image. And finally, we needed to grow the file system inside the partition before the disk space was usable. So LXD VMs use the LXD CLI interface and are a valuable container type when a shared kernel does not meet your application requirements. Anyway, that's it for today. Please subscribe and like to the channel, and don't forget to hit that notification bell, and we'll see you next time.